Hello again. This is Math 2232 coming to you from the College of DuPage, and the title of this lecture is Areas Between Curves. As always, please be an active learner as you watch this video. There are two cases that we're going to be looking at. One is going to be a case where we have things that are functions. Y is a function of f of x and y is a function of g of x. And so in this case, what you are going to do is we're going to be calculating the green area. And since this integral from here to here of g of x is going to be negative, we'll find that to get this area, what we're going to integrate is the integral from a to b, f of x minus g of x dx. Now, in words, that means we're going to be saying that the area is the integral from a to b of the upper function minus the lower function dx as x runs from a to b. We could also have a situation, though, where we have a green area over here where we do not have the red or, in fact, the blue thing having y being a function of x, but x is a function of y. And so in this case, what we're going to be able to do is, instead of integrating dx, we're drawing little slices this way, we're doing dy this way. So this is going to be the integral, the area is going to be the integral from c to d of f of y minus g of y dy. Again, we're slicing this way. And in words, that means we'll have the area is equal to the integral from c to d of the right function, the ones with the higher values, minus the left function, the ones with the lower values, from c to d. And so we're integrating dy. Let's do an example. Determine the area of the region enclosed by y equal x squared and y equal the square root of x. I'm going to ask you to pause the video and work this problem so you know what to do. Let's see how you did. Well, first thing you need to do is understand what do we mean by the area enclosed by. This means that the region we're interested in must have one of the two curves on every boundary of the region, and you want to think about what that means. So here's the graph of the two functions with the enclosed area shaded. So it's like this. I've sketched the graph so I realize that the one that's on top is the square root of x and the one that's on the bottom is y equal x squared. So this is definitely the area that we're talking about, and I need to know where do these two functions intersect. And when I set the two equal to zero, equal to one another, we find that it is going to be at x equal 1 and x equals 0. So the area then is going to be the integral from a to b. We're integrating dx in this case, the upper function minus the lower function dx. That's going to be the integral from 0 to 1 of the square root of x minus x squared dx. We integrate this one, we add 1 to the exponent. So 1 to 1/2 is 3/2, and we divide by 3/2, which means multiplying by 2/3. And then here we're going to add 1 to the exponent, so that's going to be x cubed divided by 3, and we're going to use the fundamental theorem of calculus to evaluate this, and we'll have x is equal to 1/3. This is very typical of the kind of problem I'm going to ask you to do. I will expect you to be able to do the integration, so make sure that you can do these and make sure you can do the calculations as well. Now, before moving on, there's some points that should be noted. First of all, generally, we're always going to require a graph, and you're not going to be using a graphing calculator. And so you have to be able to sketch the graph. And it can be difficult to determine which function is the upper function and which is the lower without a graph. And so you have to find the point of the intersection. And so that's solving simultaneous systems of equations. And finally, unlike the area of a curve that we discussed or you discussed in Calc 1 at the College of DuPage, the area between two curves will always be positive. If we get a negative number, a 0, that means we made a mistake somewhere and you have to go to find it. And sometimes we'll use the word region bounded by instead of saying region enclosed by. They mean the same thing. Here's another example. Determine the area of the region bounded by. y equal x times e to the x squared. That's actually y is equal to x e to the minus x squared. Y equal x plus 1, x equal 2, and the y-axis. You know what to do. Let's see how you did. So if we graph the line, we get this. If we graph the exponential, the product of the exponential with that function, you see that e to the minus x squared is going to dampen that significantly. So that will tail off like this, measuring from 0 to 2. Now it turns out the same function's on top all the time. And so the answer is going to be the area is equal to the integral from a to b of the upper function minus the lower function dx. Now in this case, we know it is between 0 and 2. The y-axis is really x is equal to 0. So we go from 0 to 2. The upper function is x plus 1. The lower function is minus x e to the minus x squared dx. Now we perform these integrations. You should do this yourself. But what we're going to get is this is going to be add 1 to the exponent divided by the new exponent. This is x to the 0, add 1 to the exponent, divide by the new exponent. And here you do a u substitution, and there's a negative involved, and so we get that. We evaluate this at 2 and 0, and we get an answer to this problem. And so the exact answer, which is what I will be asking for on tests and quizzes, is 7/2 plus, this is e to the minus 4 over 2. Now that's approximately equal to this, but the exact answer is this, and that's what I'm going to be looking for on your assessments. Let's look at another example. Determine the area of the region bounded by y equals 2x squared plus 10. That's a parabola, and a line y equals 4x plus 16. You know what to do. Let's see how you did. Well, we know that this is equal to y and y is equal to this, so those two things have to be equal. The first is equal to the third. I solve this quadratic, and you'll have to do that, and I find that this is equal to 0 when x is minus 1 and x is 3. So I'm going to be going from minus 1 to 3. When I graph the line and the parabola, I get this. The line is always on the top. So the area is going to be equal to the integral from minus 1 to 1. This is 4x plus 16 minus, and this is minus the whole of the function that's on the bottom. So this minus the whole of, those parentheses are important. You won't get the right answer if you don't do that. This is 2x squared plus 10. I distribute, collect terms, and do the integration, and I get 64 over 3. Make sure you can do this calculation. Here's another problem. Determine the area of the region bounded by y equals 2x squared plus 10, y equal 4x plus 16, x equal minus 2, and x is equal to 5. Let's see how you do. Let's see how you did. Now some students might think I asked the same problem again, but it's not the same problem because the limits are different. This one goes from minus 2 to x equal 5. So this is the piece we already computed, and we know that that integral is going to be 64 over 3. But you see in this segment and this segment, the parabola is on top. So here I'm integrating from minus 2 to minus 1 of this function on top minus the whole of the function that's on the bottom. And I'm doing the same thing over here. Now I'm going from 3 to 5. And I'm integrating the function on top minus the whole of the function on the bottom. Make sure you can do these calculations, but when you do them, you will find this is an accident, but this ends up being 64 over 3 as well. This is 14 over 3. I combine them, and I get the exact answer is 142 over 3. The next example, determine the area of the region enclosed by, these are trig functions, and we do trig in calculus too. Y is equal to sine of x, y is equal to cosine of x, x is pi over 2, and the y-axis. You know what to do. Let's see how you did. Again, you have to be able to sketch the graph of the trig functions. This is the cosine function. This is the sine function. The area between then is going to be this green area and this green area. You notice at this point, which you have to solve for, so you have to be able to solve trigonometric equations, these two are equal to one another at pi over 4. So this is going to be, the area is going to be the integral from 0 to pi over 4, the top function, cosine, minus the bottom function, which is sine, plus the integral from pi over 4 to pi over 2. Now the sine function is on top and the cosine is on the bottom. Okay, so what we're going to do is we're going to integrate each of these. The integral of the cosine is the sine. The integral of the minus sine is the cosine. The integral of the sine is minus cosine. The integral of the minus cosine is minus sine. I plug in these values. Again, you do have to be able to evaluate these. And you should know these special triangle numbers without using a calculator. And so we get this plus this. And if we add the square root of 2 and square root of 2, we get 2 square root of 2. And minus 1 is minus 2. This is the exact answer that I would expect you to tell me. Another example. Determine the area of the region enclosed by x equal 1/2 y squared minus 3 and y is equal to x minus 1. You know what to do. Let's see how you did. Again, we have to graph it, and so we graph them here. Now notice that this is a parabola that is opening to the right, and this is the line. Now, what we're going to do is we're going to do this two ways. We're going to do it dx first. So we're drawing slices like this. Now notice that if you're drawing slices like this, that from minus 3 to minus 1, the upper part of the parabola is on the top and the lower part is there. Now we're doing this dx, however, and so since we're doing this dx, that means we have to solve for y being a function of x. So we're going from minus 3 to minus 1. The function on top is y is equal to 2, the square root of 2x plus 6. At the bottom, the function is y is equal to minus. Now notice this a minus because that's how we do it. So that's what we have for the first part of this. Then when we go from this part, the yellow part, we always have this red function on top and the blue function on the bottom. And so what happens there is it's going to be this one minus the whole of the x minus 1 dx. Make sure you understand what we've done here. Well, this is going to be the square root of 2x plus 6 plus the square root of 2x plus 6. So we get that. Here we get this, and we'll do the integration doing a little bit of u substitutions. And we'll break this into two integrals. We'll do u substitutions and calculate and get 18. Make sure you follow these calculations. Now, an easier way to do the problem is to draw the slices dy, because then the blue function is always on top and you can evaluate one integral rather than 2 or 3. But we have to solve for this, so x is equal to y plus 1. So this is area. In this case, is going to be the integral from, now these y values are going to be from minus 2 to 4. That's the function that is on top, or I should say to the furthest right, minus the whole of the function to the left. We do simplification and we evaluate the integral. Again, I am going to give points for you evaluating these integrals, and so you have to get the integral, but of course the area is the same, and this way is much easier. Here's another example. Determine the area of the region bounded by x equal minus y squared plus 10 and x is equal to y minus 2 whole squared. You know what to do. Let's see how you did. First of all, we know that this is equal to x and x is equal to this, so I set the two of those things equal. and solve the quadratic, so I know that y goes from -1 to 3. So the integral is going to go from -1 to 3. And if I look at this picture, which I have sketched the graph of the two parabolas, I find out that the blue one is to the right. So that's minus y squared plus 10 minus the whole of y minus 2 whole squared. And so you simplify that, you do the calculation, and we get our favorite number, again, 64 over 3. Make certain that you can do these calculations. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. We're all in this together. May God bless you all.